Hi, hello everyone. And in this video, we will be discussing some of the basic problems in matrices. Okay, that will be help you in various examination, particularly in TRB and CSIR NET like that. Okay, so in this video, we will be discussing some basic problems on basic properties. Okay, particularly on different types of matrices, right? So on that topic, I will be discussing some of the problems here. Okay, so let's go for the first question. In a square matrices, square matrices will be a 3 cross 3 matrix or 2 cross 2 matrix or 4 cross 4 matrix. So those matrices are called square matrices. In simple words, if number of rows and number of columns are equal, so we call that as a square matrices. So each diagonal element is 0 and aij and minus equal to minus aji. So if diagonal elements, so if you have a diagonal in a matrix, so if those elements are 0 and aij is equal to aji, so if aij is equal to aji, so we call that as a symmetric matrices. Okay, we call that as a symmetric matrices. So if it's equal to minus ji, so we call that as a skew symmetric matrices. Okay, so this is what the answer is: skew symmetric matrices. So in a square matrix, each diagonal element is real and aij is equal to aij, and it is the conjugate. Okay, so then this property is for the symmetric matrices. Okay, so what happens in symmetric matrices? If we take if you have a matrix A, if you take a transpose, so then we will be having the same matrices there. So we call that as a symmetric matrices. So yeah, then which one of the condition for a matrix A to be proper orthogonal? So there are set of matrices. We call that as a proper orthogonal matrices. So that should be the determinant of A is equal to +1. Okay, so that's what called as a proper orthogonal matrix. We will come to discuss what is meant by orthogonal matrices in upcoming questions, right? So then if A satisfies the condition A dagger is equal to 1, then A will be the unitary matrices. Okay, if A dagger equal to 1, so then we call it as a unitary matrices. If A is equal to A dagger, we call that as a Hermitian matrices, and A is equal to A transpose, we call it as a symmetric matrices. So these are the types of matrices in that we have. Okay, so while solving problems, try to get the question for all the options. If you are solving for a particular question, you are getting some answer. Try to frame a question for other options also, right? So now we have two matrices A and B. So we have options here. So we have to find for A square and B square and find the correct option. So we have A square, we will just find for A square. So 0 1 1 0 and 0 1 1 0. So we will be having 0 0 to 0 is 0, 0 plus 1 is 1, and here also we will be having 0 plus 0 and 0 plus 0. So here we have 0 and 0, and here we have 1. So a square equal to 1, right? So obviously, so a square, you can now have an option A or D. Obviously we have to find for B square. Okay, so B square, so we will be having 0 minus I 0. So you have to remember that I square is equal to minus 1, right? So B square equal to, so we have another 0 minus I 0, right? So here we will be having 0 and we have minus sign here, and I square become minus 1, and this minus into minus we have plus here. Again this will be 0, again this one will become 0, and I square is minus 1, we have another minus sign here, so this will become plus 1. So both are identity matrices, so you will be having option A. Okay, then A is equal to 110i, then A inverse will be, so once you have A inverse, you have to write the formula 1 by determinant of A into edge of A. Okay, in case of 2 cross 2 matrices, edge of A can be written in this way. Okay, you what we have to do is, in the case of edge of A, you have to change the signs of these two elements, and you have to interchange this 1 and I. So here we have I and 0. So this is, we have to change the sign here, -1, 0 and 1 here. So determinant of A, what is determinant of A? Determinant of A is nothing but I. So A inverse is equal to 1 by A. Determinant of A, this is 1 by I, and we will be having I -1, 0, then we will be having 1. So 1 by I is equal to -1. That is, if you multiply with I by I, what happens? So we have I square is equal to -1, so we will be having minus I here. Okay, so 1 by I is equal to minus I, so minus I into I -1, 0, 1, so we will be having -1 minus I square is -1, so we will be having +1, and minus minus will become plus, and we have I, so we have plus I and 0 here and minus I here. So option D is the correct answer. Okay, option D, we have option D as a correct answer. So while solving this problem, we have to know 1 by I is nothing but minus I. So if you don't know this, you are not able to solve this problem, or you will be ending up in a wrong answer, right? And B square, so we have to find, for here it's, we have a diagonal matrices, so only we have diagonal elements here, so we call that as a diagonal matrices. So we have to find for B square, so B square, which is equal to 1, 0, 0 minus 1, and extremely sorry, right? So then we'll go for, right, let me write there, that location is, it's not suitable. So B square, so 1, 0, 0 minus 1, so we have 1, 0, sorry, 1, 0, 0 minus 1, so we will be having 1, and we will be having 0, 0, and -1 is +1, so it's a unit matrix, so we will be having diagonal elements as 1, so option B is correct. Okay, so if you divide each element of edge A by determinant of A, so edge A, each element is divided by determinant of A, then that is nothing but A inverse. It's a formula based question, so it's a very easy question. Okay, right. If A is equal to minus A dagger, okay, so A prime, okay, so here prime denotes the transpose. Okay, so in the case of this condition, so answer is nothing but the skew symmetric matrices. Okay, A is equal to minus A transpose, we call that as a skew symmetric matrices. So here we have a row matrix and a column matrix. Okay, so if we multiply with AB, okay, so we will be getting a single element of 16. Okay, right, here we have a matrix 3i minus 4 5i minus 4 minus 5i is equal to 0. It consists of a complex values in a matrix. So let's find for A dagger, because once you find for A dagger, we can check for Hermitian. A is equal to A dagger, then that is Hermitian. For skew Hermitian, A is equal to minus A dagger, right? So what's the definition of a dagger? So you have to take a complex conjugate and take a transpose of that. Okay, what is meant by transpose? You have to interchange rows and columns. What is meant by conjugate? If you have imaginary values, you have to change the sign of it. Okay, so we have A conjugate, so minus 3i, 4 plus 5i, and minus 4 plus 5i, and we have 0 here, and we have to take a transpose of this. Okay, so let's, what we do with transpose? Minus 3i, we have to interchange rows and columns. Minus 4 plus I by, so 4 plus 5i, 0. Okay, if I take minus in common, okay, I will be getting minus a dagger, okay, which is equal to a, which is, this is nothing but it's a skew Hermitian matrix. Okay, a is equal to minus a dagger. Okay, if I take minus in common, it will become plus 3i and minus plus 4 minus 5i. Okay, then we have another matrix, whether we have to check whether those that matrix is Hermitian or skew Hermitian, right? So let's solve for it. Okay, so again we will find for a dagger. Okay, then we will be ending up with the solution, right? So a conjugate, we can write it as 1 1 plus I, 2 1 minus I, 3 minus I, and 2 plus I, 0. And a dagger transpose is equal to 1 1 plus I, 2, and 1 minus I, 3 minus I, 2 minus I, sorry, 2 plus I, and 0. So this is nothing but A. So A dagger is equal to A. So then we call that as a Hermitian matrices, right? Okay. If A is equal to, we have a matrix. Here, check here, we have the upper triangular elements and lower triangular elements are same. So then we call it as a symmetric matrices. Okay. So Aij is equal to Aji. We call that as a symmetric matrices. Right. So now in this matrix, you can see here we have a matrix where it will satisfy A is equal to A transpose and minus of A transpose. So then we call that as a skew Hermitian matrices. Okay, then just a minute. I think there is some program background running on a background. Okay, right. So there we have a matrix. Okay, so then we have a matrix which consists of cos theta minus sin theta and sin theta cos theta. Okay, so if you find this, okay, so if you find for this, you will be finding that as it's a orthogonal matrix. Okay, so you just go and check whether this is a orthogonal matrices or not. Kindly comment the condition for orthogonal matrix in a comment box. Okay, let's move on to next problem. Which of the following matrices are skew Hermitian matrices? Okay, what is in by skew Hermitian matrices? So you have to find for A is equal to minus A dagger. Okay, you have to find for A is equal to minus A dagger. So that's the condition for the skew Hermitian matrices, right? Fine. Already we discussed a lot of problems in this skew and Hermitian matrices. The condition for skew Hermitian matrices is A is equal to minus A dagger. For Hermitian matrix, A is equal to A dagger. So kindly check the conditions for which option is correct and comment me in the comment box. And which of the following is a skew symmetric matrices? Okay, skew symmetric matrices. So obviously, uh, I think here for this you will be having more than one answers, so you can just comment the answers in this box, in the comment box. Okay, so this is slide number 9 and we have question 1. Okay, and now here we have a rank of the matrix. Okay, so if you find the if you reduce the matrices with the help of a Gauss elimination or other thing, so you will be getting only one unique rows. Okay, so the rank of the matrix is 1, right? Next, if a non-singular matrix means that the determinant of A is not equal to 0. Okay, not equal to 0, then we call it as a non-singular matrices. If determinant of A is equal to 0, we call it as a singular matrices. Okay, so it's a square matrices where the determinant of A is not equal to 0, we call it as a non-singular matrix. It's order of 5 cross 5. 5 cross 5, obviously it's a square matrices. Okay, square non-singular matrix 5 cross 5, we have an order of 5. Then the matrix is the order of 5. Okay, the rank of the matrix A is 5. Okay, if A and B are the matrices of same order such that AB is equal to A and BA is equal to B, then A and B are nothing but the idempotent matrices or idempotent matrices. If A and B are idempotent matrices, what is the property of idempotent matrices? If we have a matrix A, if we take a square, we will be getting again A. So we call it as idempotent matrices. Then A plus B will be idempotent if AB is equal to 0 or BA is equal, and if BA is equal to 0, then only it will satisfy. And A plus B is not necessarily equal be the idempotent matrices. Okay, it not necessarily be the idempotent matrices. If it is a idempotent matrix, that is, if A plus B is equal to A square or B square, then this condition should satisfy. AB is equal to BA and BA, both of them, which is equal to 0. Okay, if A plus B is also idempotent, if A and B are idempotent, it is need not necessarily be A plus B to will be idempotent. If it is idempotent, then AB is equal to BA, which is equal to 0. Okay, both of them, AB equal to 0 and BA is equal to 0. Right, right. Then I will be discussing this problem in the next class. Right, next session I will be discussing this. Right, then if I solve this, okay, so if A is equal to, we have a matrix and here we have B as another matrix, right? So then if you find for this, okay, if you find the answer for this, you just multiply. So you will be having 1 5 2, 1 into 2 is 2, 5 into 1 is 5, and 2 into 2 is 4. Similarly, you just do with this, and 3 plus 20 and 3 plus 20 and plus 2. Similarly, 6 plus 2 plus 2, and we have 9 plus 8 plus 1. So you don't need to evaluate this. They just asked for the rank of the matrices. So both the rows are unique, right? If you find the values are unique. For example, this is 9 12 and this is 6 8 9. Okay, so like this, so you'll be having 23 25, so which is 10 18. Okay, so answers numbers are unique, so the rank of the matrix is 2, right? And if for a system of m linear equations in n unknowns, the Cramer's rule is applicable. Okay, applicable if m is equal to n, because if you have 3 unknowns, okay, so we need 3 equations to find these 3 unknowns. Okay, so if you have 2 unknowns, you are not able to find 2 unknowns with 3 equations. So if m is equal to n, then only we are able to find the unknowns. So in this condition only we will be having unique solution, right? Okay, thank you very much for watching this video. So we will be discussing some more problems in upcoming sessions. Thank you.